All right, 6.2, apply properties of rational exponents.
Grab your book. They're right here. I need a piece of pencil. We need a piece of pencil. Open up.
So our properties let A and B be real numbers and let M and N be rational numbers. So, meaning they're going to be fractions. All these properties are going to be the same as like the properties that you're used to. Sometimes I don't even write them, but I'm just going to rewrite. I'm not going to give them their names, but just write how they would all work. So A to the M times A to the N equals A to the M plus N. A to the M raised to the N is equal to A to the M times N. A times B raised to the M is A to the M B to the M. A to the negative M is 1 over A to the M. Put it where it ain't, make it positive. Assuming A is not equal to 0. That's not keep, change, flip. A to the M over A to the N equals A to the M minus N. Again, assuming A is not equal to 0. And A over B to the M equals A to the M over B to the M for B not equal to 0. We have a couple properties of radicals as well. The nth root of A times B is equal to the nth root of A times the nth root of B. And the quotient property, the nth root of A divided by B equals the nth root of A over the nth root of B, assuming B is not equal to 0. And because this could come up some, when we have like a really big number, right? So like if I gave you, let's say, the square root of 28. And I want you to put that in simplest form. We probably don't need to do a factor tree for this one, but I'm going to do it just for reference. So we would have 28 breaks into 4 and 7. 4 breaks into 2 and 2. There's a group of 2. Since it's a square root, we would end up with 2 root 7. Right? You remember that? Cool. All right, well, if I have a higher powered root, I have to take them out in groups of whatever that is. So if I, for example, had, I have to make sure I'm strategic in picking one of these. I'll just do an easy one. Cube root of 81. So 81 is 9 times 9, and 9 is 3 times 3. This is a cube root, so I have to take things out in groups of 3. So this would be 3 times the cube root of 3. Okay, if it's a fourth root, we take things out in groups of 4, fifth root, groups of 5. We don't really get roots much bigger than that typically, but we would take things out in groups of whatever the number that our radical is.
Oh, that makes sense.
This section's so much better.
In the last one?
Like, oh,
Oh. Oh.
you know what I'm
You can put in the calculator. Or look at the unit circle. Exactly.
Yeah, but I didn't know how to do that.
Except for this might be a test or a quiz that you don't get a calculator for.
I don't know how to use them on the test that we do get a calculator for, so.
All right, number 4. Yeah, I was really cruel yesterday in Algebra 1. I forgot that they don't have a calculator with, like, the caret button to, like, raise something to, like, a higher power. And I gave them an interest problem that was over 20 years. So they had to multiply, I think it was, like, 1.05, like, to the 20th. And they were having, but, I mean, they have a basic calculator. They just don't have one that can, like, raise it to a power. So finally, after one of them is sitting there, like, complaining about typing this in, they're like, I don't even know if I have all of them. And I was like, I'll just type it in. Tell me what to type in. So I just, like, told it to them. And I was like, yep, note to self on the quiz, don't give them something more than, like, 5 years.
So some basic calculators, if you like press the multiply and then the equals more than once, it'll just like
Yeah.
do
Yeah,
it.
mine wasn't doing it yesterday because I tried, but yeah, some do. I don't know, like some of them you can just keep clicking it and it just keeps doing it, but I don't know. And that might be a little over some of their heads to be like, just keep clicking the equal sign or the multiply equal sign. They'd be like, huh? Anyways, it was just the whole thing. And I was like, I feel really bad.
Yeah, I think so too.
So there was one that they had to do. It was like for like 2 years or something. I was like, all right, y'all need to do that one. But then
Right.
the one that was 20, I was like, all right, everybody write this number down right now. And so they like had to all write it down. And I'm sure some of them still didn't and went home and had to multiply the numbers out because, or just wait till they got their phone after school and hopefully they know how to use the power button on their phone. All right. These ones just say to simplify the expression. So I've got 6 raised to the 2/3, all raised to the 1/2. So you don't need to write this step, but this would be 6 to the 2/3 times 1/2, which gives me 6 to the 1/3. If you were in Algebra 1, you would have to write that middle step. But y'all are not, so you don't have to. But they also aren't dealing with fraction exponents at this point. They just have numbers, so there's also that.
Sorry to hear. Okay.
8.
That's a good shot.
7 cubed over 4 cubed, all raised to the negative 1/3. Any ideas what I should do first?
Trap something in the parentheses.
You flip
Do the
them
stuff
and put it where it ain't.
Flip it first because that negative exponent's on the outside. So make this 4 cubed over 7 cubed, all raised to the positive 1/3. Now what?
Put it in.
And what do I get when I do that?
You get
Just get 4
7,
cents.
I mean 4 over 4 over 7.
Yep.
I have a question. So
I
on
might
number
have an
4,
answer.
why didn't we put 3 cube root of 6 for your final answer?
Because
Two
that's
times
not what
one.
the section was saying we needed to do.
2.
Yo, did that make sense?
What did we do yesterday?
The last 8.
A different section.
Yes.
Okay, so we can just leave it like that. We don't have to put it in the radical. Okay.
Now, if it says it needs to be written in radical form, then we would need to rewrite it. But these ones just say simplify them.
Oh.
You multiply to each of the things.
Okay, yeah.
Zach, what's 3 times 1/3? Look at that.
Do I need to write out the middle step for you?
I
Okay.
think for check it.
I had an epiphany the other day, like it was before we got to exponents, but for the longest time I just kind of accepted that something to the 0 with was 1 and not 0, and I was like, this doesn't really make any sense. And then I think I was doing like a PSAT problem or something, and I realized that like when they cancel out, like if there's nothing left, it's just 1. Like it couldn't be 0. I don't know, it was interesting,
I think it was like
but it finally
It'll make more sense when we get to logs.
Okay.
64 to the 5/9 times 64 to the 2/9 divided by 4 to the 3/4.
Ooh, I think I know. It would be
All right. What would I do specifically on top first?
10 over 9.
No. 10 over 81.
Multiply.
7 over 9. It's 64 to the 7/9.
64 to the 7/9.
Oh, yeah.
When you're multiplying things with the same base, we add their exponents. When you add, we add the tops only, the bottom stays the same. Over. Now, does this have the same base?
No.
No. Is there something I can do so that it's going to have the same base?
Multiply by a lot.
You could.
What does this up here tell me to do?
4 times 4 times 4.
There we go. What is 4 times 4 times 4?
81, 64.
64 then raised to the 1/4. Now do they have the same base?
No.
Yeah, same base, not same exponent.
I get that.
So now what do I do?
Divide.
Can I see the step you just did written out? I know what you just did. I just need to see it.
Basically that.
Thank you.
Yep. I don't really know that's the best way to write it, but that's really the only way I know how to write it. So we cubed 4.
Yep.
Yeah. I've got to simplify this, so what does that mean I need to do?
Take out a 64.
Oh, it's 7 over 9 minus a 4.
Yo.
Yes, this would be 64 to 7/9 minus 1/4. Put it where it ain't, change sign. Now, I need a, yep, what is my common denominator? 36. So this would be 64 to the what?
28 is on top. Minus 9.
So that is 64 to the, what was that, 19 over 36.
Yeah. Which cannot be.
Good job.
Now, I would leave my answer right there.
Okay.
The book, however, does not. The book says that the answer, and it is, they're equal to the same thing, but it's a whole bunch of extra work that you don't need to do. The answer in the book is 8 times 2 to the 1/6.
I feel like
Do we-
the
do I wanna
64
add?
is a lot
No.
more clear than the 8 times 2 to the 1/6.
How did they get there?
Well, no.
There's a lot of intermediate steps that they do to get there.
Because, like, to figure out the number that actually is, I have to do more work to get to the 64.
I had the first time that, because, like, we don't, depending on how the year goes, we don't always get here. Or, like, don't always cover all of this. So one of the first years, I had one of the other math teachers come to me, and they were getting this answer, and they were like, my answer doesn't match the book. And I was like, well, I typed it in. I was like, what's the same answer? And they were like, but how do they get there? I was like, a lot of work that we don't expect them to do. Like, this is sufficient. Like, yes, you can break it down farther because you've got a 36 root raised to the 19th. But that's, like, crazy. We're not, like,
We don't care that much.
because really, essentially,
If you do this, you're gonna confuse me.
well, then don't watch.
Close your eyes.
Oh my goodness.
So which is
I
then,
get it.
I get it too.
I would have never
Yeah,
seen
I mean,
I would have
so
never seen that.
Do you really?
but that's what I'm saying. Like, that's not something you would be expected to figure out, nor do you need to worry about it. It's funny. I have like half the class like this. Okay. Just, yes. But anyways, you don't need to write it that way. What I did in the box is sufficient.
Is it gone?
Yes.
Yes.
The scary stuff is gone. All right, the cube root of 16 times the cube root of 4. So this is, hold please. This is in simplify the expression properties of radicals now. So that would mean I would want to try to write my answer in radicals. But when I have this, okay, these are the same root and the things are being multiplied. So this becomes the cube root of 64, or not 64.
16 times
Yes, which is
I don't know.
64, the number I just said.
Oh.
The cube root of 64 is
4.
4. I did that the other day and something like so confidently. I was like, what is this? And I like said the exact thing that they were trying to answer. And I was like, they were like, well, you just answered it for us. I was like, yes, I did. Okay. 18. Oh boy.
No.
Should I have a new sheet of paper? I only have 3
Yeah,
lines.
yeah.
Come
me
on,
too.
again.
No. You should. I'm going to get this on one line.
Oh.
Come on,
What you said?
Alright.
The cube root of 3 times the 4th root of 3 raised to the 12th.
Oh.
It just looks weird. All right, so anytime we have a root, we can also write that as whatever the number is under the radical raised to the 1 over whatever that is. So I would rewrite this first as 3 to the 1/3 times 3 to the 1/4, all raised to the 12th.
Oh, then we both have 12 on the bottoms.
Nope.
Yep.
Or I can just multiply everything by these by 12.
That'd be my answer.
So that would be 3 to the 4th times 3 cubed, which is 3 to the 7th.
Whoa, how did you do that?
I
Pretty easy, Shepherd.
just showed how I did it.
I actually
Oh,
understood
never mind,
that.
I figured it out.
I didn't have to cover my eyes.
Algebra 1 has decided that they like my term distribute, and I'm a little hesitant on if they really understand it, but we'll find out.
They just like the word.
They just like the word.
Well, no, like anytime I give them anything that remotely looks like this, they're like distribute, and I'm like,
Is that not
That's like
distributed?
Shepherd. And
I don't think they fully understand what it means, but they kind of are getting the right thing. So yeah, it's gonna be like Shepherd's keep change flip,
But at least I don't act like that.
and like distribute the exponent only on the exponent. Disregard the bases when you do that.
I'm hungry, bro.
I gave you
And I had like a
Now, they will multiply this out because they have a calculator. I don't expect you to just leave it like that.
Okay,
No,
cool.
I'm just kidding. It was last night. What?
never mind.
Should I have a new piece of paper? Or I only have 2 lines left. Can I have a new paper on this one?
Can
I
you?
mean, may I? I mean, should I?
I mean, it's gonna be a fraction, and I'm gonna work across, so you probably would be okay. But it's up to you.
I'm just gonna do it.
All right. So on top, what I would do is I would multiply these things inside. So this would be the 4th root of 8 times 16 over the 8th root of 6.
It's the 4th root of 128.
Why?
I got
The
one.
4th root of 16 is just 2, right? So then it's just.
Which is why I didn't do it yet.
Oh,
Yes. So this would be 2 times the 4th root of 8, because the 4th root of 16, which I could have done that right here, but the 4th root of 16 is 2, so that would just be 2 times the 4th root of 8 over the 8th root of 6.
I don't know
Nice.
this.
I don't know how we got the top one.
The top one is just
Yeah.
because the 4th root of 16 is 2.
Oh,
And again,
okay.
they break these down farther, but this would be,
That's the
So
answer.
it's okay to leave a radical on the bottom of this.
if it's something like that, I will let you.
Yeah.
If it would satisfy you instead to not have a radical on the bottom, you could do it this way.
Does the problem have to be like that?
But I would take either of these
Okay.
for that one because there's not, without a lot of work, you're not going to get it broken down any farther.
Does the textbook have it getting farther?
Oh, yes. Their answer is
Close your eyes, Ryan.
2 times the 8th root of 69,984 divided by 3.
I can't close my eyes and my ears.
Yo, what?
You can close
How?
your eyes and
Oh.
hold your
I
ears.
didn't think about that.
So,
Wait, how did you?
How in the
Yeah.
world did that?
that's
How?
just
They're
what
not the
their
same
answer is.
thing.
Again, I don't know. That's why I'm saying, like, their rhyme and reason to what they do doesn't make sense. Like, yes, you can get there. I will agree with that.
Okay.
But I wouldn't.
Okay.
There's no point. If I'm going to that point, I'm going to just plug it in a calculator.
Yeah.
26. Cube root of 108 times the cube root of 4.
Well, we have to squish them together.
So we have the cube root of 108 times 4.
Ooh, I'm doing this.
You don't have to. I'm going to do a little factor tray. That's why I'm saying you don't have to. Because I'm just going to do 108 and 4. I don't have to. I mean, if you just would be satisfied by knowing what that number is, you can. But you don't have to.
It's okay, it's 432.
108 breaks into what?
I get it, okay?
98 and, whoa.
98.
9 and 12. 3, or whatever. 9 is 3 and 3. 12.
4, 3.
4 is
2, 2.
Pull it out.
And 2s.
So I can take out a 2 and a 3, and I'm left with a 2 inside. So this becomes
6. Root cube 3. 2. Right? 2's in it. Yeah.
Of 8.
6 root cube of 2. That's my favorite.
Why would it be, what about the 4?
Told you it was your favorite.
No.
The 4 is part of the
Yeah,
number.
she just said that.
She did not.
That's not what I said.
Oh, it is.
She
Yeah.
said
I
that.
didn't say you are. I said that is.
Yeah.
So she just pretended like an invisible number and divided it into 108 and 4.
That makes sense. Yeah.
That was
At
yesterday.
UC
Today's a different
yesterday,
day.
one of the first graders asked me to solve a math problem in my head, and it was like a multiplication problem, and it wasn't terribly difficult, but it took me a minute because it was like two-digit number times two-digit number, and I got it right.
I don't remember
And
how to do
I
that.
said, wow, I'm proud of myself. And they said, don't be proud, Miss Charlotte, be humble.
They just humbled you.
Got him.
My days
What
are
even
kinda
are
interesting.
It's like a religion. It's
My
like
day's kinda like
deviant from Christianity, but they believe that
Yeah,
like
mine do
electricity
too.
is like
Do you
from
think I
like
stay up
Satan.
all night?
And they
Huh?
like have
Sixth
like really,
graders
really old
with their
fashioned
math.
views.
So
It
this is
is.
very naturalist?
Helping first
Wait.
graders?
All right, what is the answer to this? I'm trying to give y'all time to do your work. If you're talking, you're not going to have any, and you're just going to have homework.
2
5 root 6. 5, 6
9.
root 3. 5, 6 root
14.
9.
I don't know.
9.
9.
6
Yeah, it is
root
9. That's what I meant to say. I don't know where I got 5, but it's
9.
9.
9.
6 square root 3.
What?
9. Root.
I don't know where I got 5, but that's what I was trying to
That's why I was confused about. I was trying to figure out where.
I knew the rest of it, I just don't know.
So, anytime we're adding or subtracting, we.
It's not working.
Shh. I'll just hand out a quiz. I mean, this is getting ridiculous. Anytime we're adding or subtracting, we treat these things like terms. They just go with it. It's just the numbers in front that are getting added or subtracted. They have to have the same root and the same number inside to do that. Otherwise, we couldn't do that. 36. 6 cube root of 5 plus 4 cube root of 625. What do you think I need to do with this one?
Combine like terms.
We have to have a
Are there any
simplified
like
one.
terms?
There are no like terms.
No.
10, 6, and 4. Oh,
Flip
never
them
mind.
so they
Simplify the
multiply
one on the
weird.
right
So they have like a fraction.
How?
number.
by doing a factor tree.
I don't like
Or I could just, well, yeah.
I guess.
All right, what does 625 break into?
5 and
And 1.
120.
5.
125.
5. Yes.
And then that's 5.
5 and
25. And that's 5 and 5.
Well, 5 cube root of 5.
So this is 6 cube root of 5 plus now 4 times 5, so 20 cube root of 5. And so I get
26 cube root of 5.
26 cube root of 5.
Where did the 20 come from again?
4 times 5.
Oh, I see.
I gotta ask a question.
48. Cube root of x to the 15th over y to the 6th. So when I have a radical with a fraction, I can split it top and bottom. So the cube root of x to the 15th over the cube root of y to the 6th. And I need to break that down. So what do I get when I do that? How many sets of 3x's do I have?
5.
So x to the 5th. How many sets of 3y's do I have?
2.
Y squared.
Yeah.
54. 3. Cube root of 4x cubed y to the 5th times cube root of 12y squared. What do I get here?
Alright.
It just all goes in under the radical.
So I get the cube root of 48 x cubed y to the 7th.
12 times 4.
Oh, that's easy.
Because x is common.
Now what can I take out?
36. No, 60.
You can take out the x to the third.
Because x cubed is cubed root, didn't it?
You could factor 48. 2 and 24. 12 and 2. There's bigger ones, Bob. 6 and 6.
Gracious, trying to make it this long. So I can take out a 2. What about the y's?
It's just 1 to the 7 over 3.
No, you can use it.
Oh, wait.
Why?
How many y's is this?
7.
7.
I need to take them out in groups 3.
So
You can
maybe
take out
2
6.
and 1/3.
So you can take out 2 y's.
So y squared. What's left in here?
Why?
Y.
Why?
Wait.
That, I don't think that.
I like that one. That one makes sense.
So 3.
Well, stop lying.
Okay. I got it.
Defensive MVP is that.
Why are you still on that, bro? Are you saying he isn't?
Yes.
Nobody else.
58. 20x cubed y squared over 9xz cubed.
Oh, we can put them together. I mean, away from each other. Everything has a radical on it, top and bottom.
So split it. Top and bottom.
Switches the low.
Now what?
We can.
Oh.
You can.
You can,
We can
Take
take
out-
out a bunch
Take
of
it on
stupid
X.
stuff.
Take it on.
Just
Oh,
for
the
reference,
ones-
I would not have done that first, but since that's what they said, that's what I'm gonna do.
Wait, take it on X.
We could,
Yeah.
well,
Yeah.
well, isn't 9 a square root of 3? So you just could pull a 3 out of the bottom.
The 20 is just 2 root 5. Oh, and then there's one y. One y on the outside and one on the in. No.
My brain is actually.
2xy root 5. And
Don't you need one more
There's
X
2
on
x.
both sides?
Yeah.
so it's 5.
Okay. That makes sense.
And what about the bottom?
The bottom, you need to
Take out a Z.
Yeah, you can take out one z and then it's just root cx.
Yeah, you can't pull out an x because it would be too late.
Now what?
You're not done.
Oh, we can.
We would not.
This is why I wouldn't have done this step first, but
Take out an X.
I can't.
Divide by X.
There's no x to divide.
Put it where it ain't.
Keep changing.
They're all positive.
Stop.
Can't do that.
Can we
Wait, I'm
make the
figuring it out.
radical on the bottom a fraction? Would that do anything?
I think maybe we should let her do her steps.
No.
Oh, we can
We're
cross
very
out the
confused.
x's by separating the root x's.
Oh yeah, because X,
What
because
do
square
you
root of
mean?
X times X root
Like
of
square
X.
root of x times square root of z on the bottom and square root of 5 times square root of x on the top. And then we could just cross out the square root of x's.
I wouldn't do it that way, but technically I guess that will ultimately give it to you.
What?
Ew.
I'm still not done though.
Wait, what would
Still-
you do?
Don't
What
you
would
wait,
you
let
do
us-
in place of what we just did?
Yeah,
Wait,
can you-
let's just finish solving it this way, and then maybe
No.
she can show us the way she would solve it after.
Yeah.
No, I think we messed it up this way.
You are gonna rather see the way that I would have done it. It's easier. But I'm finishing this one first.
Can I compromise for this one, then what's your way?
Yep.
Yeah.
Okay.
Yeah. Yeah. You understand. That's why I know we have to do that.
Alright, so the first thing I would have done over here is I would have started simplifying before I ever did this because I ended up with way too many steps in here. So x into x cubed, that's going to give me up here 20 x squared, y squared over 9, z cubed. And then I would have, without actually splitting it, I mean you can split it, but I would have gone straight to 2xy root 5 over 3z root z. And then multiply by the root z. Top and bottom.
So how did we get?
Isn't it supposed to be x cubed at the beginning?
No, I got rid of the one on the bottom. That's what I did differently than what's up here. That made life easier.
Okay.
And where did we get? Wait, no more.
Should always reduce stuff first.
3 times 3. So we took out a. We did. Oh, we cube rooted 9.
Square rooted
We square rooted 9 and got
3.
3z squared, right? And then
No, I got 3z
3z
times the square root of z. Take things out in groups of 2.
What out in groups of 2?
Z cubed is z times z times z. I took out 2 of them.
Oh, because we square rooted the bottom.
You are so smart.
Thank you.
All right, problems. 3 through 47, every other odd, and then 53 and 57.
We can